while I'm here, I want to start that in case you didn't notice over there. Your homework will be page 12 in the packet, questions 3 through 7. So you'll notice on page 12, it starts with, I asked you to highlight stuff and then use a red colored pencil. You don't need to do 1, you don't need to do 2. You're starting with 3 through 7. So just basically the questions on that page. So this is homework due Tuesday. Okay. All right, so you said we didn't finish page 10. Let me see how much we had left. All right. So it sounds like we needed to, it sounds like we have to go back to page 10 real quick. No problem there. Okay, so on Friday, we talked about the convection currents, and I compared the convection currents to a conveyor belt, like the conveyor belt at a grocery store that you put your groceries on when you are cashing out. So if the convection currents are rising and going out like this picture is showing, the conveyor belt's going to behave the same way. So that conveyor belt, oh, and now I switched it here. Sorry, so in this picture, the conveyor belt will be moving out from the center here and the continents would be spreading apart. So did we get convection currents? Is that where, so we left off here and then we started talking about rising convection currents. So like the ones here in the picture. So they're coming up and the currents are moving apart. So the conveyor belt will also be moving apart. So for rising currents, this is actually going to cause the tectonic plates to move apart. So we are on page 10 where it says rising currents. We're just filling this in. Apparently we did not finish on Friday. So you guys know about plates, and that's actually where we're going to go today. When I say plates, whoops, hang on. This is Ritz. Okay, yep, okay, bye. So we talked about plates, they move around, they bump into each other, they make mountains, they pull apart, they cause earthquakes. But one thing that can happen is when the convection currents are rising like this, the conveyor belt is going to pull the plates apart. We can do the opposite when we have these convection currents right here where they're coming together and sinking. That's going to cause the plates to come together. So falling currents cause the plates to move together. We're going to be spending the whole rest of today talking about what happens when plates move around. Now what I'm going to need you to do is grab page 5 of the reference table. We're going to skip the bottom part here for now. We're just starting page 11. Thank you. We're just starting page 11. So like I was saying, when plates move apart and plates move together, this is caused by convection currents. So we're going to be focusing in on page 5 of our reference table. We already worked with page 5 before. the map of the world. We did page 5 when we talked about latitude and longitude. So you should have the equator labeled. You should have the prime meridian, the north, south, east, and west labeled. When we were talking about latitude and longitude, I told you to ignore what was going on in the background. Today is when we're done ignoring that. So some of the stuff that's going on in the background is instead of the continents being labeled with their names, like this doesn't say the North American plate, or it doesn't say North America, it says the North American plate. Same over here, it doesn't say Asia and then Europe over here. It's combined into one plate called the Eurasian plate. The other stuff that's going on is they show where these plates are touching or where they're banging into each other or pulling apart. These are called plate boundaries. So wherever these plates, you can see down here, they give you a key down at the bottom of the reference table. Anytime two plates are touching, that's called a boundary. And based on this map, we can see what's going on at that boundary. So the arrows actually show us the relative motion. This doesn't mean it's telling you exactly where the plate is going. For example, if we look here at the Pacific plate, the arrows that are on the Pacific plate are going pretty much every which way. So we can't easily say the Pacific plate is moving north or the Pacific plate is moving south or east or west. What you can do with these arrows is compare the Pacific plate to what its neighbor is doing. So for example, up here at the Alluvian Trench, and I know you can't, my arrow's covered up. Right there at the Alluvian Trench, you have two arrows pointing together. So what do you think's happening at the Alluvian Trench? Okay, they could be building mountains. So two plates are coming together is what I'm getting at. Yes, they could be building mountains. That's different than over here at the Pacific plate, Nausicaa plate. What are those two plates doing? They're pulling apart. And then we have actually one more type right here at the San Andreas Fault. They're not really pointing towards each other. They're not pulling away from each other. What they're actually doing is sliding past each other. What's happening here is North America's here. The other side on the Pacific plate's there, and they're doing this. So they're not doing this. They're not colliding, they're sliding past each other. So you don't have to memorize any of this because if you look down at the key tells you in pictures what's happening. So we're going to start with divergent plate boundaries first. So if you look down at the key for divergent plate boundary, let's take a look at the arrows for divergent plate boundaries. Can you tell what's happening at divergent plate boundaries? What could we say the plates are doing? So I saw a couple people show me with their hands, but I need that in words. What are those two plates doing? Moving away. So you could say it a couple different ways. Moving away, pulling apart, separating. At the very top, and I know you have to write kind of small, for divergent plate boundaries, it's a location where two plates are moving away from each other. Now you don't really have to memorize this, because the picture told you. So again, if you look down at the key, it shows you that the two arrows are moving in opposite directions. So if you forget what diverging means, you just take a look at the reference table and you're like, oh, okay, those are arrows moving away from each other. The next one, we're just going to go across to the paper. We're going to do all three of these first. Convergent is the next. Take a look at what those arrows are doing there. So based on the key, what do you think it means if there's a convergent plate boundary? Yeah, they're pushing together. And again, you can word that slightly different ways. They're coming together, pushing together, running into each other. I say convergent plate boundary is where two plates come together. They're basically having a head-on collision. And the last type of plate boundary that is listed there on the reference table that we're going to talk about is this transformed plate boundary. Again, by looking at the picture, with this key, this plate that's on top and this plate that's on boundary or on the bottom, they're sliding past each other. So they're not colliding, they're not pulling apart, they're sliding past each other. So transformed plate boundary is where the plates slide past each other. We're going to be spending the rest of the period going into some details about these two types of plate boundaries. But one thing I do want to point out is your homework, which is on the back of this page, is all using this reference table and just getting familiar with this reference table. So it's just going to go send you on like a scavenger hunt on the reference table. There's really no thinking required with this. It's just searching the reference table. It might take you a hot minute to find each one of these things that's on there, but I promise you they're all on there. You just have to go searching for them. So your homework, I could have you starting your homework right now and you need nothing that I'm going to talk about for the rest of the period just to do your homework. All right, so that's that, but back to the rest of the notes. We're going to be talking in detail about each type of plate boundary. So I do want to continue on with divergent. You already wrote this. You wrote this at the top for divergent. Now we're going to go down the column for divergent. Before we start looking or doing notes, let's just grab your reference table again. If we were to study the divergent plate boundaries, in fact, that's what I want you to go do. Search the reference table for all the divergent plate boundaries. So you're looking for the key. You're looking for, it's almost like a staircase situation there with the arrows pointing in opposite direction. So here's some, here. So those are all the divergent plate boundaries on this map. I don't think I missed any. Where are all the divergent plate boundaries? Study your map there for just a second. Let everybody think for a second. So study the map. There's something in common with all of the divergent plate boundaries. What could you say about all of that? Go ahead, somebody want to. They're all in the water. Divergent plate boundaries happen underwater. So again, divergent plate boundaries are where plates spread apart. So now one more thing on there, what are they all called? So they're all in the water, but what are they all called? They all have names. Yeah, ridge. I heard somebody say it. So we got the southeast. I think that's the southeast. Yep, so, no, that's the southwest Indian Ridge. This is the southeast Indian Ridge, the mid-Indian Ridge, East Pacific Ridge, and the Mid-Atlantic Ridge. So what is made at every divergent plate boundary? What's made at every single divergent plate boundary? A ridge. So divergent plate boundaries make ridges. Is this something you have to memorize? No, why not? Because right there, you just look at the reference table and see every single divergent plate boundary is a ridge. So I didn't even put a place for notes there. What's a ridge? What is a ridge? Okay, I saw some trades. What's at Chestnut Ridge? Have any of you been there? There are. Who goes to Chestnut Ridge in the winter? Never? You guys have better places to go. You guys even know where Chestnut Ridge is? Nope. That's a dilemma. There's a good sledding hill there. Chestnut Ridge is a very hilly park in Erie County. So a ridge is a hill. Has anybody actually been there? No? All right, well, that's the devil's out of the windows. Anyway, it's a hill. It's not a mountain. You don't go there to go skiing. And that's why you guys live closer to mountains for anybody who actually skis. You guys just go over to Elecantville. You guys got more fun places to go. So a ridge is like a little, it's a hill. It's not a mountain, but it's a hill. And so that's what's going on at all of these. These are like underwater, many mountains, many hills, underwater. You've got this picture in your notes. This is an example of a ridge. So going with this map, let's say we're doing this ridge right here. So we have North America on the west side and Europe and Africa on the east side. So if I had this, we would have USA over here and we'd have Europe over here. Right? So we've got Europe on that one side and it's a ridge. So the plates are moving apart here. So I want you to picture, we're gonna pull apart some plates. By the way, what are plates made out of? What layers of the earth? What? Crust and wood. I hear a bunch of mumbling, but I can't hear anyone actually talking. No, that's what they're floating on. So, okay, so review from Thursday. The plates are made out of the lithosphere. So that's the top skinny layer of the earth, remember? Page 10 of your reference table, we've got lithosphere. It's the crust and rigid mantle. So it's not just the crust, it's part of the mantle. And they're floating on the asthenosphere, so that gooey, ooey layer. So when the plates pull apart, what's that leave open to come up now? So we pull apart the lithosphere, we look down this new craft, what's there? Not water, the asthenosphere, the ooey gooey layer. So we are in the water, but we're taking the floor of the ocean and we're pulling apart the ocean floor. And underneath the ocean floor is not more water, but is that ooey gooey asthenosphere. Hot liquid lava. What's that liquid lava going to do when it touches the ocean? Harden. It's going to become an igneous rock. I like to say that these ridges are where baby rocks are made. So baby rocks are made at these mid-ocean ridges. So when I say baby rock, when brand new lava cools and hardens into a new rock. So mid-ocean ridges are where baby rocks are made. That's where the youngest rocks in the world are found. Right this very second, baby igneous rocks are being born at this mid-ocean ridge. Right now too. And right now. I think you get the point. To explain mid-ocean ridges, I like to compare it to kids. Do any of you guys have 3 kids in your family? Mm-hmm. No, I want just 3 siblings. So we're gonna go with Miley. Miley, are you the oldest, middle, or baby? Oh boy. Miley's a baby. Miley, who's the oldest? Kylie. Oh man, I'm gonna not Kaylee because that'd be too easy. So Kaile. No, K Y L. Oh, that's easy to spell. Kylie. How old is Kylie? Do you know off the top of your head? She's 27. She's old. Got 27-year-old. And who's the next kid? Haley. Oh, you guys all end in E. I like it. So we got Kylie, and how old is Haley? Oh, perfect. Whoa. Kylie got to hang out as an only child for 8 years. Who's an oldest kid? Oh, you guys are going to relate to this really good. I'm an oldest kid. So this part you guys are going to relate to. You babies like Miley, baby kids, you're not a baby. Baby children are not going to understand what we're talking about at all. Oldest children, what happens when your sibling's born? They get all the attention. You're pushed to the side. You're kicked out of the crib, practically living on your own and raising yourself at the age of 2, right? At least that's what it feels like. And maybe I'm being sarcastic. Yes, I am. I've never kicked my oldest kid out, but boy, did I feel like I got kicked out. Anyway, Kylie got to live her life for 8 years as the only child. And then when Haley came along, what happened to Kylie? She got kicked out of the nursery. So if the babies are born at the Mid-Ocean Ridge, it's like the nursery. And get kicked out when the new baby comes. H-A. Oh, normal Haley. Haley is born. Kylie got pushed away. Unlike kids, I know you just told me how to spell your name, but I'm probably still spelling it wrong. Kylie got pushed away. Not only do rocks get pushed out of the nursery, they get split in half and pushed away from the nursery. So now baby Haley is occupying the nursery. Kylie got pushed out. 4 years later, closest to pretty sure, 4 years later, the baby comes along. What happens to her sisters? They're out of there. Now we got Miley. Oh, Miley, I'm gonna do it to your name too. M-Y-L. We had to switch it up there. Miley's now living the life in the nursery. What happened to Haley? She got kicked out. I spelled it wrong, didn't I? No, I did it right. Haley's now living down the hall. What happened to poor Kylie? She's gone. She is living in the garage practically. I know I did that one wrong now, but you would think I could spell, right? I can't. Poor Kylie's living down the road now. This is how it works with rocks. Every time a new rock is born, it pushes the siblings out one layer. And this is how rocks work. This is not how real houses work. I do not think this is what happened. Everyone is loved. My children are loved equally. I swear to goodness sakes. What? 11. That's how my husband, like, he got kicked out at 11 months. He was raising himself at 11 months old. Yeah. No, I don't think that's really how it works. And no, as parents, we don't have favorites, just ones that we prefer at one moment over the other. That's all. No favorites, but each one has their pros and their cons. I will admit to that. So every time new baby rocks are born, they come up at the Mid-Ocean Ridge and they push the older rocks out to the side. So how this works is if you go to the Mid-Ocean Ridge, that's where the youngest rocks are found. That's where the babies are being born. And then as you take a step out each way, they get older as you go out. But the key is that these rocks right here, so one side on either side of the baby, are the same age. So these are still the Haley rocks. And then they get older as you go out to the Kaylee rocks. They get older as you go out. Does that make sense? Okay, so the babies are found at the Mid-Ocean Ridge and the oldest rocks are found over by the continents. All right, there's one more thing here. You may notice that there was a key here that says normal and reversed polarity. You guys remember about magnets? You probably learned about them 4th, maybe 5th, maybe 6th grade science. What do you remember about a magnet? Anybody remember anything about a magnet? There's a North Pole and a South Pole. You might remember that opposites attract, likes repel. But one thing I'm not sure if you remember or we even taught, a compass. Like a compass that tells you which way is north. And not our phones. Our phones don't work this way because our phones work with GPS. But an old-fashioned compass will point north because it's a magnet. And it's just like a magnet like that. And it will point north. Well, do you guys remember magnetite? The mineral magnetite? What's the fancy about magnetite? It's magnetic. So basically it's little magnets. Well, magnetite is found in some of these igneous rocks. So when these rocks are born, they basically have little magnets in them. And just like a compass, north points north, north points north, and south points south. So they have little compasses in them. Well, what the rocks right now are being born with their magnets pointing north and their north pointing north and their south pointing south. What scientists have discovered is that they go out to the slightly older rocks. We're going out to the Haley rocks. They're reversed. And as you notice, it's called reverse. So instead of north pointing north, south will point north. And they're reversed from what we expect. So on each side of the Mid-Atlantic Ridge, they're reversed. Now, you don't need to know why, and you don't need to know how this happened. You just, as 10th graders, need to know it's happened. And how can we tell? Because we can go out one layer from the ridge and they're reversed. What do you think happens when we go out one more layer out to those Haley rocks? They got reversed again, and that's called back to normal. And we call it normal because it's what is normal for us today. So as you go out, and then if there were older siblings out even further, it would be reversed again, and then back to normal again. So again, you don't need to understand why or how, you just need to know what happened. And this is called paleomagnetism. So this is the next thing that you have to write. Thank you, Kaylee, for sharing your family history with us. I like your names. Thank you, Miley, for sharing your family name. Now I know your sister's name is going to mess me up. So these paleo, and I'm sorry, you have to write small. I did it though, so you can do it too. So I know I just talked a lot about that, and that whole reversal thing is really confusing and weird. For this year, what you need to know is that they're the babies, the youngest rocks at the ridge, and they get older as you go out. And then they also switch polarity as you go out. So not only are they the same age, like on either side of the ridge, they're also the same polarity. So this just proves the crust has shifted. So the seafloor is spreading at these ridges. It's spreading apart, and it is called seafloor spreading. The rest of the evidence that the floor is spreading apart is, so again, if you were just asked, how do they know that there's divergent plate boundaries? One of the reasons is that the ocean floor is younger than the continent. So those baby rocks are being born in the ocean. And you can also prove it by looking at that magnetic reversal. All right, it looks like this is a good spot to start. We could do one more, but it doesn't make sense to keep going there. I'll leave that up there for anybody who's still typing or writing. You do have homework. Page 12. You don't need the notes to finish page 12. The page 12 is all on the reference table. Guys, who's not going to be here tomorrow because you're going on that BOCES field trip? I feel like I signed a bunch of papers. All right, even though you're not going to be here, I'm going to finish the notes on this page. And you will have homework. Just because you're not here does not mean you get a free pass. Everything will be posted on Teams, including a video to help you with it.